Hi, I'm Steve Taylor. Today we're going to talk about agentic platform engineering. It's the future of automation. Today, automation has hit a ceiling, not because we lack the tools, but because our automation model is static. Platform engineering is the shift from automating tasks to automating decisions. Today, we're going to take a look at how Temporal can help us solve this problem and shift into automated decision making. So I've been doing this for a while. I've implemented automation to support secure software factory floors my entire career. I've worked with the Linux Foundation on their technical oversight committees. I'm one of the lead contributors to one of our open source committees called Ortelius. I've taken a lead at technical conferences, teaching tough subjects, and also done mentorship for our community. So let's talk about pipelines today. The pipelines that we have currently, they're linear and they're brittle. They're brittle because anything can break them. You get a test case that fails, it breaks them. If you get a tool that just stops working, they fail. If you have a coding problem in the source code, they're going to fail, like a build failure. And because of this, we exit our pipelines and then we just stop the whole pipeline from running, and then we're off to human intervention again. That's not how it should be. We need to have automation work for us, not against us. So this is where agentic platform engineering comes in, because it adds a layer of decision making to our pipelines. And that decision making is above the pipelines themselves. It's orchestrating the pipeline process, all the steps in it. And instead of asking, what is going to be the next step in our linear process, the agentic pipelines, they're going to ask, what am I dependent upon? When I focus on what my upstream dependencies are, I can then determine if I have the correct outputs from those dependencies as inputs into my current step. They allow us to really adapt dynamically and continuously shape the workflow on the fly without having to stop. None of this human intervention that we see in our current pipelines today. So we're going to take a look at our demo today. And in our demo, we're going to focus on two main flows. The first flow is going to be where our linting is executed. We have a lint failure. That lint failure causes us to take auto remediation path, and that creates a PR for us with the coding fixes. The second pass, after we merge that PR back in with the fixes, we actually go through the full pipeline. So we do our linting, our build push, signing, SBOMs, vulnerability checks, and attestation. Why this really matters is because we're actually changing the pipeline on the fly. We're making decisions in the pipeline, doing AI remediation, using some MCP servers to make it happen. And as a result, we get our SALSA level 3 compliance. We get provenance, our signing, our SBOMs, verification, auditability. Everything is recorded, not whether it's automated tasks that are happening in the pipeline or our manual steps, such as the PR approval. So just another quick look at the process, just a little bit easier to visualize. We're going to go through the megalinter step, and that's being run by our temporal orchestration. If there's any errors found in our megalinter, like in our first scenario pass, we'll actually exit over to Claude. We'll pass the details from megalinter to Claude, and Claude will actually do the auto remediation on our code base, and then talk to our MCP server to create a pull request. So that's our first scenario where we have the linting failure. Now, after we do our merge of our fixes, we go through the full path. So we do the megalinter again because we want to double check, and then we go on to generate our SBOM, do our build, our vulnerability scan, our signing. And again, if we have a vulnerability that was found that's high or critical, we actually exit out of the pipeline again. We create an issue and pass that back to developers to fix. If everything's good, we have no higher critical vulnerabilities. We attest everything and verify our signatures and attestations. And then that's where we wrap up our pipeline. And that gives us our full SALSA level 3 compliance.
So today we're going to take a look at using Temporal's workflow orchestration to run a SALSA level 3 pipeline over on GitHub using the GitHub Actions, Claude AI, as well as the GitHub MCP server. With all these tools, we'll be able to run the pipeline and have it orchestrated automatically by Temporal. So what we're going to do here is we're going to check in some code that has some linting errors. That will go ahead and run through our linter. We'll find that there's errors that need to be fixed, and then Temporal will pass over to Claude the list of errors and the files that need to be fixed. Claude will fix those for us, and we'll create a pull request. After that, we'll then go ahead and take that pull request, merge it in, and run end to end. So let's go ahead and get started here with pushing our code up. Let me just go ahead and commit and do my git push. Okay, we got our push done. And we'll jump over to Temporal and our GitHub Actions here so we can watch what's happening. So we can see our run salsa pipeline has just started. This is the trigger that is going to be used to talk to Temporal. So this is actually going to trigger our Temporal client, and we'll start running our megalinter. So if I go ahead and refresh this side, we can see that the job has taken off. And if I scroll down, we can see where we are in the live monitor here. So if we go back to our actions, we have now two jobs running, the trigger job and then the megalinter. Now, because I had a coding errors, this megalinter is going to go ahead and return those errors. So this job here on the GitHub side will actually fail, but that's fine. We're going to catch those errors and then do our AI remediation as part of that. So now we can see that megalinter has failed. So our workflow on the GitHub side has stopped. But if we look over on the Temporal side, we can see the remediation taking place. So we get our files with the lint errors. We analyze those files with Claude. We talk to the GitHub MCP to create a new branch. We push our files and we create our pull request. And then we mark that we have a failure as part of our process. So if I go over to our pull request now, we can see our auto-fixed pull request. This was all generated by the Salsa pipeline through Temporal and the MCP servers. And if you look at our files that have changed, we have our linting errors fixed here. Now I'm going to go ahead and merge this now that the code looks all good to me. And we'll basically start the process again. So if we go back over to our actions, we can see that our run salsa pipeline has taken off again, but this time it's working against a new commit that I just merged. So as part of this path, we're going to do the megalinter again, but this time it'll be successful. So then we're going to move on to build and push, signing, verifying, those type of things that we have to do to create a salsa level 3 pipeline. So again, here we're at the megalinter run stage, and this will be followed up by the build stage because we're going to have a successful linting this time. So if I go back over to our workflows, we have a new workflow that's running. and we can see that it's taken off. So we can see on the temporal side that the linting was successful, and now we're going to go ahead and execute the build. So the mega linter this time has the green checkbox, good. Now we're doing our build and push. And this is happening because we're on the success pipeline, where earlier we're on the failed side of the pipeline. Now that the build has been completed, we're going to go ahead and do two other steps. We're going to sign the image with a cosign, and we're going to generate an SBOM. This is actually being done in parallel because these two things are independent of each other. So now that the SBOM has been generated and we sign the image, we can go ahead and scan that SBOM for vulnerabilities. This is another point where we can take another failure branch. So if we do find high or critical vulnerabilities, we can branch off, stop the pipeline, and go ahead and create issues to make sure that those high and critical vulnerabilities are resolved. We were all good, so we're actually just attesting the SBOM back to the Docker image. So basically the SBOM is embedded in the image along with everything being signed. And finally, we're going to verify all of our signatures. So just to ensure that nothing's been compromised throughout the pipeline, we go through and verify the Docker image, the SBOM, all those signatures to ensure that everything is good to go for production. And this will finish up here in a second, and we'll have a complete successful run. And there we have it. We have our complete successful run all the way through. So just to recap, our first pass, we had those linting errors. We ran our pipeline orchestrated by Temporal. As part of that pipeline, the linting errors were found. We were able to take a remediation path that we talked to Claude, fixed those linting errors, recommitted, basically created a PR with those coding changes. And then after I reviewed the PR and I merged it, we started a second run of the pipeline again, this time walking through all the steps from the mega linting all the way through the end of verifying the signatures successfully. So how did we get there? How did we make all this happen? So basically there's two pieces that we have. The first piece is the orchestrator. So you can think of this as your pipeline steps. What is your pipeline going to look like? Let me scroll up to the top here. And the way I've written it is to use state transitions to determine the order of what things are going to happen in. Working along, everything's looking good. We don't have any linting, or we don't have any linting errors. We can pick different paths. So there's what I call a set of presets to say I just want the minimal presets, just lint and build, or if I need to skip linting because it takes too long, I can pre-configure those presets. As part of the process, we can go ahead and inject different states into the process. So if we need to take a fixed path, we can inject that in there automatically. Again, this is based on state flows. So there is actually a state, what state are you at and what you need to run. So if we actually go look at this definition, this is basically our initialization, defining what we need to do. And then here's our linting step that we're working with. Now, what ends up happening is the linting step at the orchestration level then talks to the activity. So we're going to execute the activity run mega linter, and that's defined as an other file. So if we look at run mega linter, this is where the heavy lifting happens. So in this case, we need to talk to GitHub that's doing all the heavy lifting for us. So we're actually using the GitHub APIs to figure out what workflows are running and how to kick workflows off and get the results back. So in this case, we kick the workflow off, and then we go and check for it to be completed. And then we come back and download basically the results of the mega linter. So Megalinter, you can save all of its results as part of a JSON file. So we take that output and we merge it back into our result. Now, one of the things that the state mechanism that I'm using is we set it up so it depends on, so a particular workflow step depends on a previous step. And when we have that depends on, we can grab the results from those upstream activities that ran. So it makes it very nice to set up our workflows. So I can say, okay, I'm going to add a SCA tool into my pipeline. What is it dependent upon? Is it dependent upon linting? No, it probably is just dependent upon maybe the build. We need the build to complete. So I can set up these dependency relationships very easily without having to know who's dependent upon me. I know what my input is and where I need to gather it from. So it makes it very simple at that level. And also it'll handle the different paths because the state machine is set up to handle the auto injection of a new state. We can take the different paths as part of that process. So with that, I'll just wrap up and say thank you. If you have any questions, just reach out to me.